Hello everybody, in this lesson I will explain an extremely difficult rider on angle at center. There is your cheat sheet with all the theorems we have discussed so far. I suggest you look at the sketch while I give you the information. In the sketch, AB is the diameter of circle O. A second circle through O and B cuts circle O in C. Chord CD of circle O cuts the smaller circle in E. AD, DB, BC, CO, OE and EB is drawn. Number 1. We need to prove that AD is parallel to OE. Now, can you remember when we have parallel lines, there is this thing we used to call fun in lower grades, where when you have parallel lines, then you say these two are corresponding angles. And then the U of the fun was these two are interior angles supplementary, or we had something we called alternate angles. So if we can prove any of the three there, then we know that they are indeed parallel, line AD and OE. Now let's see, when we look at this sketch, there's no midpoint. So the only theorem that we can really use there on a circle ADBC is the fact that A1 is equal to C2. So we can say A1 is equal to C2, and the reason, angle in same segment, and you will see that it's chord DB that subtends them. Furthermore, we can say that angle C2 is equal to O2. Now let's have a look. C2 is equal to O2. And why can we say that? Again, it's the smaller circle now, and its angles in the same segment, and they are being subtended by chord EB. And then what can you see? That both of them are equal to C2. Therefore, we can say that angle A1 is equal to angle O2. So there you find A1 and there you find O2. And can you see, in fact, the two lines are parallel, and your reason will be, since corresponding angles are equal, the two lines are parallel. Question 2 wants us to prove that BE is equal to DE. Now let's see. Let angle D2 be equal to Y. So I'm going to add the Y there. Have a look. O1 is equal to 2Y. And why can you say that? The angle at the center is twice the angle at the circumference. So I'm going to add there 2y. And the chord that subtends them is chord CB. Then we can say that angle E2 is equal to 2y. What's your reason? Angle in same segment. So this little one there is also 2y, and it's chord CB that subtends them, and that's happening in the small circle. Then E2 is equal to D2 plus B3. Now why can I say that? E2 is the exterior angle of a triangle, is equal to the sum of the opposite interior angles. So if you have a look at the sketch, there's E2 for you, and then it's the exterior angle of the triangle DEB. So it's equal to D2 plus B3. B3 is therefore equal to y. And what's your reason? Since D2 is equal to y. Therefore, we have that line BE is equal to DE. And what's the reason? Sides opposite equal angles. In the next lesson, we will have an in-depth look at the theorem angles in same segment. Click on the video in the left-hand corner to take you straight to the next lesson.